So, one of the first things that I think of when I'm converting a fraction into a decimal, or indeed a percentage, as the question was really about, was that the fact that we might know certain things. We might know that a quarter is the same as something out of 100. And that this thing that we know is helpful because when we think of a percentage is really always something out of 100. And that's the link that we're always trying to establish. So let's say, for example, the first thing that we find out is that we have 3/12, and we want to know what 3/12 is as a percentage. What is 3/12 as a percentage? Well, the first thing that we might want to do is simplify that so that we have the simplest form of that fraction. Once we've established that, then we can go somewhere from there. Now, if we go back to that thought that we had at the beginning, that a quarter is equal to something out of 100. What can we do? Well, we know that there are 25 fours in 100. If we counted in fours, it would be the 25th multiple of 4. And so 1/4 is the same as 25%. You may already know that. You may already know that already. And so as soon as you've got to a quarter, you might therefore think, therefore, 3/12 is the same as 25 out of 100, which is the same as 25%. However, this equivalent fraction way, you might fall into some difficulties when you think of going straight from 3/12 to something out of 100. Why? Because if I look for that link between 12 to 100, how many 12s go into 100? Well, there are 8.333, and that keeps going. In fact, there are 8.3 recurring hundreds. That's one of those never-ending stories that doesn't really help us. So we might need to switch to method 2, which is to calculate the decimal and from there convert to a percentage. Now, any decimal, let's take 0.25, is really easy to make into a percentage. 0.25 becomes 25%. Just like 0.47 becomes 47%. You might think of others. You might know, for example, that 3/4, 0.75, is the same as 75%. Can you spot the pattern? Calculating a decimal to a percentage is very, very straightforward as soon as you can see that pattern. So, as long as we can get our fraction into a decimal, we're off and away. Let's have a look at 3/12 again. 3/12. Well, that's the same as saying 3 divided by 12. What is 3 divided by 12? Well, I can just quickly resort to my written methods here and say, well, what is 3 divided by 12. We know, of course, it's not going to go into 3, so we're going to go into decimals. 12 into 30, well, that's going to go twice, the second multiple being 24, so that will be a remainder of 6, and 12 goes into 60 5 times. 3 divided by 12 is the same as 0.25, which is the same as 25%. Useful. Very useful. Particularly when we think of the awkward example that was sent in. The example that was sent in was, what is 13 over 31 as a percentage? Let's try method 1. Method 1 says, find your equivalent fractions and work from there. So method 1 says, well, 13 over 21, let's get a more friendly fraction. Oh, we can't. Why is that? Why can't we find a more friendly fraction? Why doesn't method 1 work here? Well, you may have noticed that the numerator is a prime number, the numerator being the top number, of course, and the denominator is not a multiple of the numerator. So we're in a bit of a tricky situation that we can't make that fraction any simpler. Let's try method 2. Remember, we're trying to do something with 13 over 31. Well, method 2 says that 13 over 31 is the same as 13 divided by 31. And then I can quickly resort to my written methods and say that 13 divided by 31, we know it's not going to go into 13, being larger than 13, of course, and we're going to go straight into decimals. So it goes, we end up with 130. Well, I think if I wrote out my multiples of 13, it goes something like this: 31, 62, 93, 124, and so on. I'm going to stop there because that might be enough. I can see that the first multiple is right here. It's 124. And of course, that is the 1, 2, 3. That's the fourth multiple, so it goes 4 times into 130, and there's 6 left over. Does it go into 60? It does. It only goes once, though, doesn't it? Because the second multiple is too big. So it goes once with 29 left over. If I carried on my multiples, I'd find out that it would go in 9 times. And that would probably keep going, wouldn't it? So I know that 13 divided by 31 is going to be 0.419 and some more bits, which is approximately equal to, 42%. Because, of course, I would look to round it just here. And the 9 being higher than 5 tells us to round up to the next one. And that gives us 42%. And like that, we can convert 13 over 31 to 42% using our method 2. Hope that proved useful. Keep your questions coming in, and I'll see if I can help with any other questions. Take care. Bye now.